The Destiny Laboratory module is the location where much of the US-sponsored research aboard the International Space Station is performed. In this element and other dedicated science modules, astronauts and cosmonauts perform hundreds of experiments each year for commercial and public purposes in areas ranging from material science, chemistry, to physics, to medical research. All of this with the aim to better understand Earth, humanity, and prepare for eventual human missions to the Moon and Mars. Destiny was the first of several dedicated research modules launched to the space station to facilitate what would eventually become a rush of scientific and commercial activity aboard the ISS. Before we get into the video, I want to welcome all new subscribers to the channel and thank everybody for leaving comments and engaging in live streams. I really appreciate it. As such, I recently set up a Discord server where we as a community can continue to talk about various human spaceflight topics outside of YouTube. I also want to say that it is my goal to eventually focus on orbital velocity full-time, so I've set up a Patreon page if you want to help support me in my efforts to do so and create more and better content for the coming years. You can follow the links on the screen, they'll also be in the video's description. If you can't support orbital velocity financially, that's perfectly alright. All you need to do is watch this video, give it a like, and share it with your friends and family, and subscribe to the channel if you haven't done so already. Now let's get right into the video and learn about the Destiny Laboratory module. Ever since the final Skylab crew left the first US space station in February 1974, NASA sought to send another permanent research laboratory into space. While the space shuttles offered the capability to do orbital research for up to 2 or 3 weeks at a time, the orbiters couldn't stay in space forever. Initially, NASA hoped to restore Skylab during the first few space shuttle missions. However, its orbit decayed sooner than anticipated, and it re-entered Earth's atmosphere in 1979. The first space shuttle mission happened to be in 1981. Eventually, plans were announced by then-President Ronald Reagan in 1984 to build a large modular space station using the space shuttle. It would be dubbed Freedom, and in many ways be an answer to the Soviet Mir space station. Eventually, the Japanese Space Agency, the Canadian Space Agency, and the European Space Agency would join the project. All three organizations looked to contribute large research laboratories aboard the multinational space station. However, between redesigns and cost overruns over the course of a decade, the program was nearly canceled by the US Congress. An amendment in the 1993 NASA Appropriations Bill would have removed all space station funding. However, it failed in the House of Representatives by a single vote. Later that year, in a meeting between NASA and the new Russian Space Agency, it was agreed to merge the Freedom Space Station concept with the successor to the Mir space station into an international space station. The overall station was scaled back to accommodate budgets, but research laboratories for Japan, the United States, and Europe and Russia were still planned. Construction of the US laboratory, dubbed the Destiny module, finally began in 1995. Built by Boeing at NASA's Marshall Space Flight Center in Huntsville, Alabama, the $1.38 billion module was shipped to the Kennedy Space Center in 1998, with launch processing beginning in August of 2000. Overall, the Destiny module is about 8.5 meters long and about 4.3 meters wide, with a pressurized volume of 105 cubic meters. Its mass before adding the various science racks is about 14,500 kilograms. Its structure comprises 3 aluminum and stainless steel cylindrical sections and 2 intercones with berthing mechanisms on either side. The aft is passive and is used to connect the Unity module, while the forward is active and initially a temporary location for a pressurized mating adapter before being the permanent home for the Harmony module. In the center bottom part of the module is a 50 centimeter diameter window, which is typically used for high quality photos and videos for Earth observation. The center part of the 110 meter long integrated truss structure would later be connected to the top of the Destiny module. Inside, the module has slots for 24 refrigerator-sized racks, 6 on each side. Like all modules on the US orbital segment, they support international standard payload racks, which allow for interchangeability throughout the US side of the outpost. Each slot is about 2 meters high and about 1 meter wide. After being loaded into the payload bay of the Space Shuttle Atlantis, it was launched into orbit during mission STS-98 on February 7, 2001.
Space Shuttle Atlantis with Destiny, a science laboratory for the 21st century.
The vehicle's now in a heads-down position on course for a 51.6 degree, 201 statute mile orbit.
2 days later, Atlantis arrived at the fledgling ISS, which at the time only had 3 major modules and 2 truss segments with solar arrays installed. The orbiter docked to PMA-3, located on the space-facing side of the Unity module, before the crew entered the outpost to greet the space station's 3-person Expedition 1 crew. The next day, 2 astronauts went on a spacewalk to assist in the removal of PMA-2 from the forward port of Unity to the manual berthing mechanism on the forward side of the Z1 truss in order to make room for the laboratory. Destiny was then grabbed in the payload bay and flipped around before being berthed, increasing the habitable volume of the ISS by 41%. It was soon entered by the shuttle and station crews. 2 days later, during the second spacewalk of the mission, astronauts were tasked with helping to move PMA-2 to the forward end of Destiny, where it remained until the Harmony module arrived in 2007. Also during the second spacewalk, a power and data grapple fixture was installed on the lower part of Destiny to allow the Canadarm2 remote manipulator system to be attached when it launched later in 2001. A shutter was also installed on the window of Destiny. Once the shutter was opened, the protective blanket was removed, allowing the crew inside to view the astronauts outside. For the third spacewalk on February 14th, a spare communications antenna was installed on the outside of the ISS, and a third cooling radiator was released on the P6 truss. Atlantis left the space station on February 16th and returned to Earth on February 20th. When the module was launched, it included 5 systems racks, mostly fitted with computers and other systems that provided power, cooling water, and air revitalization and temperature control. Once the lab was activated, it allowed for the transfer of all ISS operations from the Russian Mission Control Center in Moscow to NASA's in Houston. Additionally, the equipment aboard the Destiny module allowed for the final activation of the 4 control moment gyroscopes in the Z1 truss, meaning the primary attitude control for the outpost would be maintained on the US side. The Russian side's thrusters would still be used as a backup or for more complex orbital maneuvers such as orbit raising. Additionally, the systems of the Russian segment would continue to be maintained using its own modules while still being connected to the US side via the Unity module for some powered data transfer and other operations. An additional 6 systems racks, as well as the Human Research Facility, the first science rack on the ISS, were added a few months later when the STS-102 mission brought the Leonardo Multipurpose Logistics module. Over the coming years, the lab would gain many racks, including the Microgravity Science Glove Box, the -80-degree Laboratory Freezer, or MELFI, and WRF, the Window Observational Research Facility. On the outside of the space station, Destiny would gain an external stowage platform to hold equipment on the outside of the outpost for use on spacewalks. Destiny was also one of the most important components of the ISS, as it allowed for the beginning of the construction of the integrated truss structure. Starting in 2002, the S0 truss would be attached on top of the lab, with power and data cables attached, to begin routing power and cooling throughout the entire complex. Once completed, the integrated truss structure would comprise 9 pieces, hold 8 massive solar array wings, 4 outbound radiators, and 2 sets of 3 rotational radiators near the center of the outpost. In 2007, Destiny would no longer be the front door of the US segment. When the Space Shuttle Discovery delivered the Harmony module, its final location would be the forward end of Destiny and the connection point for 2 international laboratories for Japan and Europe. Today, the lab is used to perform science experiments in all sorts of fields of study, including materials science, fluid dynamics, combustion research, and Earth observation. In 2005, the ISS was designated as a US national laboratory. In 2011, the primary responsibility for managing all non-NASA research fell to the Center for Advancement of Science in Space, CASIS, which is now just called the ISS National Laboratory. Since then, Destiny, as well as other parts of the outpost, have opened up this unique orbiting complex to more than just governments. Private companies, universities, and non-profit organizations have all been able to send payloads to the ISS for research, outreach, and experimentation. The Destiny module and the international research laboratories to follow pave the way for a growing orbital marketplace for commercial and public research and development, a system and practice that could one day soon make its way to deep space outposts such as the Lunar Gateway. What do you think of the Destiny module, and what's your favorite part of the ISS? Let me know in the comments below. If I've earned it, it'd mean the world to me if you could subscribe to the channel if you haven't already, and share this video and others with friends and family. It helps support the channel and also lets me know what topics you're all interested in regarding human space exploration. And if you're able, consider supporting Orbital Velocity on Patreon. Depending on the level you pledge at, you'll get access to graphics and content not used in videos, as well as your name in future videos published on the channel. You can also follow Orbital Velocity on Twitter and Facebook. Additionally, you can visit orbitalvelocity.com for even more space-related content, including a monthly newsletter called The Space Capsule. Links are in the description below. Thanks again for watching, and until next time, ad Astra.